Okay, DJ, so here's 11.4, number 3. Let's see if we can't be a little bit more efficient than the first one there. So this time we're doing 3. What's the first thing we're going to do is they gave us the derivative. Remember, this is actually y prime now, dy dx, right? We're going to set it equal to 0 to find our equilibrium values. So our equilibrium values are at 0 and at 2. Okay, so let's go ahead and do our phase line. So we're going to have y0 here, y2 here. We know it's going to approach or reach equilibrium there. Okay, so now what? Well, again, taking y minus 2, let's plug in, let's say, -1. That's to the left of 0, right? So notice I get a negative times another negative. So that's why I knew it was positive. You see? In between 0 and 2, let's plug in 1. That means I get a positive 1, and 1 minus 2 is a negative 1. Positive times negative means the slope is negative. So notice how this one is positive slope going towards 0 from the left. Negative slope means it's going back down to the left towards 0. So we know that 0 is stable. Okay? Well, what about 2? Well, we already know the slope is going away, and if we're clever, we know it alternates. So greater than, less than, greater than, or positive. Positive meaning it's going away. The slope or rate change is positive. It's growing away from 2. So since it's going away, both left and right of 2, 2 is unstable. So far we know our equilibrium values are 0 and 2, and we know 0 is stable, but 2 is unstable. Okay? So now what? We got to take the second derivative, right? So our first derivative was y squared minus 2y. I went ahead and just times it together, right? Y squared minus 2y. And now that's going to make me do the second derivative a little bit easier. I know the derivative of y squared is 2y, y prime, minus 2y, when I take the derivative, is just simply minus 2y prime again, right? And now I can factor out the y prime, and I'm left with 2y minus 2, which is a 2 times y minus 1. We know that y prime originally was y minus 2. So now we have our second derivative. Okay? So now what? Let's do a phase line for our second derivative. All right? So notice I already went ahead and put in the information on the first derivative, but now we're going to do a similar thing on the second derivative. So let's say we plug in -1, which is to the left of 0, right? And if I plug it in there, I guess I ought to show my work a little bit here, right? I have it here, but I guess I'll just kind of clean this up. There we go. There we go. So I'm going to plug in -1, which is left of 0, right? Our first equilibrium value. So again, right here is my second derivative, DJ. So imagine me plugging in -1. I'm going to have a negative. -1 minus 2 is -3. That's another negative. I have a positive 2, of course. And -1 minus 1 is a negative. I have 3 negatives, correct? So that's how I knew the double derivative was negative. Now, to save time, we know it alternates. We know it's negative, then positive, then negative, then positive. Now, the one thing I forgot to remind you is we needed our inflection point. In other words, our inflection point will be right here, right? Because when is this going to equal 0? We already know 0 and 2 are our equilibrium values, right? But y minus 1 tells us our inflection point. So we know it's 1. So now we're ready for the last part of the question. Okay. So I've already kind of experimented with this. Let me refine it here a little bit. So I know that here is 0, here is 2, here is 1. Now remember, 1's our inflection point. Okay, somewhere along that is our inflection point. It doesn't have to be right there on the x-axis, by the way. But anyways, if I know my slope is positive, then that means I know it's going up. If my concavity is negative, that means instead of going up like this, see, this would be concave up, it's concave down like that. See, it's kind of starting to curve in a downward direction. So that's why I knew it would have to do something like this. Okay, and we know that point zero is our equilibrium, so it's going to do something like that. Okay, now what about right in here between the 0 and 1? Our concavity is positive, means it's going to be more like that, while our slope is negative. So as it goes down, as you can see right here, it's actually trying to curve back upwards, you see? So hopefully you kind of understand concavity. Let me make it very clear. This is concave down, this is concave up. This is concave down going positive. This is concave down going on the negative side. This is concave up going on the negative side, or sorry, concave down going on the positive side. Hopefully I didn't misspeak before. And this is concave up when the slope is going upwards. Anyways, hopefully you're starting to get the idea there, DJ. All right, finishing this up, I know from 0 to 1, it should be concave up but going down. So I know it's doing something like this. It's going down but concave up. But then on the other side of 1, 2, it's concave down when it's still negative. So somewhere here is an inflection point, is kind of doing something like that. Okay? And then finally, right of y equals 2, or I should say above y equals 2, we know our slope is positive while our concavity is positive. So that's how I know it's going to go upwards like that, something like that. Okay? So anyways, that's about as close as I'm going to get it, DJ. So I don't know if the teacher is going to teach any of this or bring it up to you, but that kind of gives you an idea of how these functions work. Okay, so I'm just going to save this one and start up the next one.